Hey everyone, and welcome. Today we're going to tackle a classic physics problem that has a really clever twist. It's one of those puzzles that's perfect for testing how well we really understand the way forces work. Okay, let's dive right in. So here is our setup. Pretty simple. We've got two identical blocks, each has a mass of m, and they're connected by a string. Then we pull the front block with a force we're just going to call F. So the big question is, what's the tension, T, in that string holding them together? Go ahead, take a second. What's your gut reaction?
Now, if you're like most of us, an answer probably just popped right into your head. But here's what makes this such a great little brain teaser. The most common first guess is actually wrong. So this isn't just a problem to solve, it's a bit of a mystery we need to crack. Okay, let's look at our lineup of suspects. We've got A, F, B, 2F, C, F divided by 2, and D, 0. Now I bet that first one, suspect A, looks really tempting, doesn't it? The force is F, so the tension must be F. It just feels right. But as we've already hinted, there's a little more to this story.
To solve this mystery, we can't just guess. We need the right tools for the job. So let's do a quick review of the fundamental concepts. These are the clues that are going to lead us straight to the answer.
First up is force, the F in our diagram. It's the engine of this whole operation, the push or pull that gets our blocks moving and accelerating in the first place.
Next up, we have mass. You can think of this as an object's stubbornness, its resistance to being moved. The more mass, the harder it is to accelerate. And in our puzzle, each block has a mass we're calling m.
And finally, tension. This is the star of our show, the internal force that we're actually trying to find. It's the pulling force from the string itself that drags that second block along for the ride. This is the heart of our mystery. All right, with our tools all laid out, the investigation can officially begin. And you know what? The key to cracking this entire case lies in one of the most famous, most powerful laws in all of physics, Newton's second law. You've heard it a million times, F equals ma. This is the evidence we're going to follow.
This slide right here, this is our whole strategy. Before we can find the tension, which is just a part of our system, we need to analyze the whole system moving together. It's a great trick in physics, and this first step simplifies everything.
Okay, let's follow the evidence, one step at a time. First, we look at the whole system as if it's one big object. The total mass being pulled is m plus m, so that's 2m. That means the equation for the whole train of blocks is F equals 2ma, easy enough. Second, we solve for the system's acceleration. Just a little algebra gets us a equals F divided by 2m. This number tells us how fast both blocks are speeding up together. Third, now we can zoom in. Let's isolate just the rear block. What's the only force pulling it forward? It's the tension, T. So for step 4, we apply Newton's law to that block alone, which gives us a nice clean equation, T equals ma. And now for the final step, the moment of truth. We substitute the acceleration we found in step 2 right into this equation from step 4. And with that final piece of evidence locked in, we are ready to close the case. The math has led us directly to the answer. So let's finally reveal the identity of our culprit.
So when we plug in our value for that acceleration, the equation becomes T equals m times the quantity F over 2m. And here's a really satisfying part. The mass m on the top and the m on the bottom, they just cancel out. The physics simplifies itself beautifully.
Leaving us with our answer. The tension in the string is exactly half of the pulling force, T equals F divided by 2. So, let's head back to our lineup of suspects. We can now definitively say it wasn't F, it wasn't 2F, and it certainly wasn't 0. The correct answer, proven by the evidence, is C, F divided by 2. But this brings us back to the original question. Why? Why isn't the tension just F? If you pull with F, shouldn't the string also pull with F? Well, this is the aha moment. It all comes down to what each force is actually responsible for. That main force F has a big job. It has to accelerate both blocks, a total mass of 2m. But the tension T has a smaller job. It's only responsible for accelerating the rear block, which is a mass of just m.
So the crucial point is this. The tension only has to do half the work because it's only pulling half the mass. The main force F is accelerating the whole system, but the tension T is only accelerating that back half. Once you see it that way, the answer F over 2 stops being a tricky math result and starts feeling completely intuitive. The initial guess was wrong because it didn't account for the two different jobs these forces are doing.
So we've cracked the case for two identical blocks, but physics puzzles always have another layer, don't they? What do you think would happen to the tension if the front block was heavier than the back one? Or vice versa? The principles we just used today will give you the answer. Something to ponder. Thanks for joining me on this Explainer.